Hi there. This is the fourth hour of practicing refactoring with me. We're going to continue on our journey to doing the Gilded Rose refactoring kata to a reasonable degree of effectiveness and also to completion, hopefully. And not in that order. I hope we complete it before we get good at it. So I'm just going to set a timer here for, let's go 60 minutes. I've taken care of the project setup this time because even though I'm the only one watching this, if anybody else ends up watching these videos, it's a lot of me fiddling around with my very fussy development environment. And I'd rather not inflict that kind of viewing pain on people who take the time to watch my videos. So we're all set. I think this will actually run the first time. Yeah, it does. And so we get a failing test, but that's expected. And the other interesting bit is that, well, that isn't particularly interesting, and there is no other interesting bit. So the thing that we're going to be doing is trying to refactor the fairly ugly Gilded Rose update quality method into something that is amenable to changing the types of items that it updates. Because the requirement of the Gilded Rose kata is to add a new type of item, a conjured item, and those conjured items degrade in quality twice as fast, I believe. I might be recalling incorrectly, but that's the goal. All right, so let's get after it. To start, what I usually do is just a little bit of stylistic stuff. So removing some unnecessary white space and adding white space in order to make this a clearly delineated four-phase test. And those four phases are setup, exercise, setup, exercise, assert, and then tear down. There's no tear down in this method, but that's fine. So the other thing we might want to do is just use require relative rather than the like the overly verbose require that was in there before. I'm going to continuously test this. It doesn't look like it's necessarily picking up. There we go. All right, so we're good to go. So we're getting fast feedback here, which is good. And we get a test failure, but that's okay because we're just doing stylistic changes to spec. All right. So for our first non-stylistic change, let's make this test pass. We can see that the spec is specifying that update quality doesn't change the name of the items that's passed in. The original name is foo, and so this should be foo as well. So let's see, green. All right, let's commit. Okay, so for our first bit of testing, what we really want is a set of characterization tests, and characterization tests are defined in this really excellent book called Working Effectively with Legacy Code by Michael Feathers. He talks about tests that are used to characterize all the behavior of a bunch of code that you'd like to refactor. And the reason that's useful is when we refactor, we want to change the structure of the code without changing any existing behavior. And so characterization tests are really necessary for that. I'm going to be using a tool that makes kind of creating these characterization tests straightforward. And that tool is called approvals. Essentially what approvals does is it's a set of helpers that let you generate a file, and that file contains inputs and outputs. And then anytime that you make a change to a test, it will ask you to approve the changes to the inputs and outputs. That's a fairly vague explanation, but you'll be able to see what I'm talking about in a second here. So what we want to do is open up our gem file, not our fem file, our gem file. It's pretty, our file search isn't working very well. Actually, before I do that, let's get like a better directory structure in place. Maybe that'll help us with the file search. Ruby projects usually have a spec and a lib, or a spec or a test and a lib directory. We'll just toss that in there, and we'll toss that in there. And what we end up seeing is this should be lib gilded rows. And we should get, so we get passing test. Just call this project, add structure to project. Oh. And we can hit that. All right. Next, though, we want to add in this approvals tool. I happen to know that approvals also wants rake. And so I'm just adding that preemptively to get around some error messages that I know. Oh, I'm getting some GPG errors. I don't know that I really want to get into it. Well, that worked. I'm not quite sure why I'm not quite sure what the issue is there. Let me see if there's an approvals binary. Yep, and approvals. Okay, so that's fine. Let me see if this is quick to debug. Oh, it was very quick to debug. Okay, so maybe maybe Git just needed like a credential helper or something. Let's open up our spec again. Okay, so the way that approvals works is we need to require approvals, our spec, and we said that these are characterization tests, so we'll use a name that indicates that. Approvals gives us this, not that verify method, but a different verify method. And that verify method will take the result of evaluating the block and it will use that as the it'll essentially write the output of that to a file. And anytime that changes, we will have to manually approve any changes to the output. And that'll let us, first of all, very quickly add all of the interesting outputs from the update quality method to the file. And then after that point, it allows us to catch anytime we change outputs. We might, depending on how careful I am, we might hit those changes and see those test failures, but we also might not. I'm going to be pretty careful about my refactoring. But suffice to say, what we want at the end is items. That's what we'd like to approve on. Those items, it's going to look very similar to our first test up here. And the only tricky part is generating this items array. And so we know that the item constructor takes a name, a cell, and a quality. So we're going to want something to generate names, sellins, specifically all of the interesting names, sellins, and qualities. And we're just going to generate an item object for each of those. Whoa. Okay. So let's take a look at what that will, or let's think about what this this items array is going to be. It's going to be a set of names, and we're going to take all of the interesting names, all of the interesting qualities, and all of the interesting sellins that we can kind of divine from reading through the code very at a surface level. And we're going to take the cross product of that so that we can get every single combination of interesting combination of name, sellin, and quality. And there's a helpful method in Ruby on array called product, and it takes a list of arrays, a variable number of arrays, and returns an array that is the cross product of all those. So our names are going to be a bunch of interesting things. Our sellins, or our names are going to be an array. Our sellins will be an array as well. And our qualities will be an array. And actually, let's just borrow the values from the first test. So to kick this off, I think we actually want to see I do not need to debug this. As a very small click target. We have a failure here, and we can see the approvals like test framework is giving us an error that this is characterized.approved.txt is not found. And we can generate that by running this approvals verify tool. And it will, here, I'm just going to pop that open so it's a little bit bigger. It'll use, you can configure a specific diff tool, but out of the box, it'll just use diff. And it'll show us what we're trying to add to the file. And we can choose to approve or disapprove of it. And it will basically rename what's in this received file or to the approved file. In this case, we can see that we're getting this this kind of stock Ruby inspection string, and it includes the object ID itself, but that isn't what we're going to want to approve on because that's going to change every time, and so we're going to always get a diff, and approvals is always going to fail our test what we want is something more stable. So an output that's only going to change if the inputs change. And in that case, I think if we take a look here at the item class, we can see it has a toS method that contains just the attributes set in the initializer. And so that's going to be a more stable output. So we don't want that, but if we verify, oh, actually, let's just run that again. We can see now we have a stable output. So we have foo, -1, and 0. So we can approve that. And we'll just say first approval. And let's start working through the interesting inputs to the function. So, to the update quality. I guess it's more of a procedure than a function. It's not just foo, but it looks like there's this aged brie string. So let's add that. And I just want to. So we get another approval error here, which is expected. And we can run that approvals verify tool again. And we can see that it has added the aged brie item. So let's do yes. And let's commit approval for aged brie. All right, now let's see about this backstage passes item. We should get a failure because we've changed it. And if we verify, we can approve it. And we can change this to backstage passes. That's what we are approving. Next thing is this hand of reg or sulfurous item name. So let's, oh, I did not copy that correctly. Oh, trying to use my keyboard here. So we should get another failure because we haven't seen sulfurous yet. And yes, we can approve that. All right. Let's see if there are any other items here. We got aged brie, backstage passage, sulfurous. All right. So we've covered that. Let's think about sell-ins here. So we look for sell-in. Let's look for them all. So we have sell-in less than 0 is one of the conditions. What we want to do is hit every interesting input. And when I see a condition like this, an interesting input is usually either side and equal to whatever, specifically with a numeric input, you want either side of the comparison. All right. So now we can see we're generating a lot more test cases. So we just generated a whole bunch more. We're just going to say yes because we're just going to say yes because those are whatever the code is doing right now is valid. We don't want to change it. So what we can do, I'm just going to use a generic name for this, add approval, because we're going to be committing a bunch of these things. So we have sell-in is less than 0. Sell-in is less than 6. So let's put 5, 6, and 7 there. And that we're going to add another approval. Okay, we can see that we have this cell in less than 11 as well. So we'll do 10, 11, and 12. You kind of get the point of this, right? We'll see a failing test. We will approve, commit. And that does it for selling. We have that case, and that case already. Let's dip down to quality here. So quality greater than 0. Let's do a similar thing here. -1, 0, and 1. And then we have 50. So let's do 49, 50, and 51. Got another error. So this is pretty mechanical, but that's what we want. We don't really want to understand this code. We just want to change the structure of it. We don't need to understand it until we actually add the new feature. Okay, so we've hit every case of the quality too, because it looks like all the checks the interesting checks are on this 50 level, and that also that 0 level. So that is good. And actually, we can be doubly confident because this green gutter is the code coverage, and we can see all of it's green. There is no red here. So we're fully covered, and we're actually ready to refactor. So what I'm going to do is I'm going to close the test for now and just focus on the production code. To start, let's do a little bit of cleanup. We'll get rid of these unnecessary parentheses, try to do things a little bit more Ruby-ish. The tests are passing, so we can commit style X's. And one of the things we can do here, let's see if there's a built-in introduce field. Might be, oh, okay. That's interesting. I wonder if there is a way, I was hoping there was a way to turn this into an adder reader. One thing that I do like to do is make sure that, oh, that we use it's the principle of uniform access, I think. And it's just so that we don't have more than one way of referencing a variable. And it also helps if we ever need to refactor this items to return something else, which we may or may not later on. So I'm just going to say add attribute is probably a good name for what we're doing in that commit. And that leaves us with this update quality method. It looks like what it does is it iterates through each item and it updates it somehow. We don't know how yet, but one really easy refactoring we could do right away is just to extract this method. We can call it update item. And so now update quality actually reads pretty well. If we ignore update item for a second, we take all the items and for each of them, we update the item. We could even, it might even be worth renaming that to just update. Yeah, let's do that. And we can do the refactor. And our tests are passing. So we're gonna go through each item and update it. That's good. Let's just call that extract method. All right, so I think update quality is in a pretty good place. Let's look at update, which is obviously not in a good place. One of the things that we're gonna wanna do here is take each of the conditions and kind of make it clearer what happens under each of those conditions. And the way we can do that is we can just take one of the interesting conditions that we see here and we can create an empty if to start with. We want to make sure we're making little changes. So we'll say introduce if. That's what we're doing in there. And then what we want is to run this same code on either side. Because what we'd like to do is make sure that we're not changing the behavior yet. And so the safest change is to run both code and both sets of or the same logic in either branch. And the way we can do that is by extracting a method. We don't care what it's called. I always use applesauce as the placeholder. And the reason for that is it's such a ridiculous name that you probably will rename it or get rid of the method itself before basically pushing to prod. This would never pass code review, and so that's why I use it. Okay, so we have this applesauce item. Now it's safe to push this into either branch. And we should see our test pass. Right. So duplicate, we'll call it outer expression or something. That seems okay. And then what we want to do is inline this method. And we don't want to keep the method around, obviously. Okay, the following problems are found. Inline method refactoring is not supported when the return statement interrupts the execution flow. I actually know why this is happening. So Ruby is an expression-based language, which means that every expression, there is no, basically, other languages have things called statements and expressions. In Ruby, everything's an expression. So this item.quality equals actually has a return value to it. And so depending on the path that we take through this like big gnarly if statement, the value returned by the method is going to be different. Fortunately for us, we don't care even a little bit what that returns. So what we could do is make our first change, and we could have it return a totally, we could just make sure that the method returns basically a same value every time. We're not going to pass any items in because we don't need to. And we can expect, basically, I want to expect that when I call update quality, that I always get the object itself back. And this is usually a good API design, a good default API design for any method that you'd call like a command method as a contrast to a query method. So command method, you're telling an object to do something and you don't care about the the return value. So it can be useful for you to get that object back as the return value so that you can chain on other operations, usually more commands. So it looks like we're getting an empty array, which is fine, but let's make it not do that, and we will return self from both of these branches. Oh, that's interesting. Okay, we'll return self from this branch. Okay, and that actually means we can return nil from here, because we could return anything we want from there. Actually, why don't we return self? No, we'll return nil. And actually, I'm going to back that change out because this is a good place to commit. We're going to say return self from command. Now I will introduce nils and inline these methods. Maybe I shouldn't put it there. Maybe I should put it here. All right, now we're done. Okay, and I don't need this little refactoring panel anymore. I want to watch my test pass. You can see now that we've got this test coverage in the gutter here, and red means that the code is dead. So we can start to delete some of this code. Remove dead code. You can see that this also isn't run. So we are going to remove dead code again. You can see I'm committing pretty frequently. All of this isn't run. And this isn't run anymore. Okay. And now what we can do is we can start to simplify these if statements. So we can see that this condition, if item.name equals hbree, implies that item.name does not equal hbree. We can totally change this to be false. And that means this whole statement is false, which means that the else always runs, and that is the equivalent logic, basically. So simplify if. And this never runs because it's an empty if. And we can see this has an empty statement, or item name does not equal hbree. We already know that's false. So we can lift that. If item name doesn't equal sulfurous, we already know that's true. Okay, and we now have all of the logic that runs just when hbree happens. And we can continue to do this if simplifying. So if item name doesn't equal hbree, in the else branch, it's always going to be true. And so true and whatever is equivalent to whatever. And so we can do that. And if there's any other hbree in here, if item name doesn't equal hbree, we know this is true. Oh, actually, before I do that, we are going to call this simplify condition. Oh. And then we can do the same for down here. So if item name doesn't equal hbree, we know this is true. So we actually know that this always runs, and that has an empty else. So this is even simpler than before. So we will call this simplify if. Okay, and so now we've done hbree, and things are looking a lot better by peeling out that condition. The next thing that we need to do is probably peel out this backstage passes condition. We can say our first bit of refactoring that we should do is probably extract this method. And we can call it applesauce again, because it's going to live a very short life. And what we can do now is add the else if item.name equals, whoa. There we go. Backstage passes. We should get passing again. Okay, we're good. We can commit this, call it lift condition. And then we're going to inline this. And we will call that inline method. All right, so we're doing okay here. Let's go through the dead code removal process again. So we're gonna red, that's red. All of that is also red. So this whole thing here, that is dead code, which is good, and that is dead code. So that's a bit bigger than it needed to be, but we will commit that all at once. And now we can do this simplification. We know we know that an item name is equal to backstage passes, so the else always runs here. We'll lift that up, and we already know that item name equals backstage passes, so this is equal to true. So we can just replace it with its body. If item name doesn't equal backstage passes, well, it does. So we can lift that up and bring those out. If item name doesn't, and now we're in the else side of things. If item name doesn't equal sulfurous, we know this is true because it equals backstage passes. So we can just kill that altogether. Again, I'm taking bigger steps than I probably should have. But you'll let me get away with it because at least I have the test telling me that I'm not breaking anything. Now let's see if we can simplify any of this. We know here that it doesn't equal backstage passes, so we can lift all that stuff up. We know here that it doesn't equal backstage passes. These have empty else's, which is kind of a giveaway. And so we've simplified the ifs on that side, and we're now down to just the one item name case. We could have left the commit message there. And it's just going to be this sulfurous method. So let's extract our favorite name. Okay, so we have the condition lifted. I should commit the extraction itself and then the condition lift. And then we can inline and remove the method. And we're going to get to dead code city here. So this doesn't run, this doesn't run, this doesn't run. And then all of this does run, which is interesting. But I think it's because we have that foo item. Remove dead code. All right. This is an empty if, so it doesn't do anything. This also doesn't do anything. That doesn't do anything. This is an empty if. That's an empty if. That's an empty if. Wow. So sulfurous isn't a very interesting item. We can call that removing dead code. None of that executes in a valuable way. Okay, we're left with the kind of base item. If the item name doesn't equal sulfurous, at this point in the if statement, this is true. And so we can do that. The same logic applies here, and the same logic applies here. And so now we're left with the simplest logic. Available for all the different kinds of items. So we have aged brie, backstage passes, sulfurous, and every other kind of item. We can see that the shape of the aged brie method, or the aged brie logic, I guess, and the base case logic, if you squint, I can't really tell with them so far apart, but they do look different. And so what I'd like to do is maybe swap the position of the aged brie and the sulfurous, because sulfurous, it almost seems like a guard condition, right? But we won't make that choice until we can take a look at kind of refactoring out each item individually. Okay, so what I want to do is move this condition down in this giant switch statement, basically. That's going to involve moving this up, killing those 3 words and adding them there. Let's call that moving sulfurous up. Let's just see. Now I'm free to push this right to where I want it, which is, and I only want it there so that I can compare. And the reason that I want to compare is because I want to start dealing with some of this duplication, and the rules for dealing with duplication are spelled out in this excellent book by Katrina Owen and Sandy Metz called 99 Bottles of OOP, I think. And the rules for dealing with duplication are called the flocking rules. Basically what we want to do is identify 2 chunks of code that look similar, find the smallest difference, and then make a change to remove that difference from the two chunks of code. So let's see what we can do here. We see that the conditional here is different enough that I don't want to deal with that right now. And even the delta in quality it's a positive delta here and a negative delta here. This next line, item.selin -1 is the same in both areas. And since there is nothing, like no condition wrapping it, and we don't do anything with selin beforehand, I think it's safe to move those up. Okay, so it is. And actually, there's also this item.selin here that we can move up. Oh, but it looks like weirdly enough, by moving it up in the backstage passes case, we actually have changed the behavior there. So let's maybe back that change out right now. Okay, let's take a look at this, because it doesn't look like selin changes, but it does look like selin's compared against. So it might actually not be such a wise idea to have that be our first change. Okay, but maybe there's something else we can do. In Sulfurous, we aren't changing this at all, but it is changed in every other item branch. And the one thing that we could do to make things at least a little bit simpler is add that selin change in there. And so we're going to introduce duplication, actually, but that duplication makes each branch a little bit more simple or similar, and that's what we're looking for. Is you want to take the smallest difference and remove it, but that removing that difference doesn't mean removing the duplication. It might mean introducing new duplication. And I think I actually removed nil from there. I don't think I need to do that. All right, so add selin change. Okay, so what else can we do? We do this item.quality is less than 50 here. Item.quality is less than 50 in aged brie. And item.quality is greater than 0 in the base case. And then we actually manipulate the quality based on some threshold, right? So what we could do is say the thresholds here, we've got item quality is less than 50 and item quality is less than 50. So that's exactly the same. But in the base case, we have greater than 0. So this is actually the same as being less than infinity, right? There might actually be just a straight up infinity constant now. That would be cool. Uninitialized constant infinity. Who'd have thunk? All right, so it's float infinity. Well, I don't know how I've changed this to be different, because it does seem to me that being greater than 0 is the same as being less than infinity. But I guess -1 is also less than infinity. So This is really interesting. Maybe there's some kind of way to put a lower bounds on some of these changes too. So if I put if item quality is greater than 0 and it's less than 50, does that change the behavior in a meaningful way? Yeah, it does. Okay. Well, we're just going to back that change out altogether. Well, one thing we can do, one little refactoring we can do, is get rid of this nil in each of the branches and just push it down below. We're basically going to execute all that code and then return nil no matter what. So remove branch duplication. And we can also consider, I think that this is actually a fruitless effort to try to introduce that duplication there right now. So we're going to call that remove no op. And instead, let's do something a little bit more obvious. We'll extract update backstage passes. Update aged free. And finally, we can extract a method called update basic item. Okay, so each of these looks pretty interesting. We now have the basic update logic extracted into each of these methods, but it'd be nice if we could have some objects. So let's think about how to do that. We have this item down here, but it's not pulling its weight in a huge way. What we could do instead is have oh, actually, let's do this too. Update sulfurous. Right? And that can basically be a no op. So now we have something that's very uniform, that has a structure we can work with. And what we'd like to end up in usually with Ruby code or any kind of OO code is an objects that use polymorphism to abstract away the conditional logic underneath. And then usually what you want is to lift that conditional into something that constructs an object. In this case, we want to construct an item from, or almost an item updater from the name of the item, and then we want to update it. So the way we can do that is by introducing a class one by one. So we'll make a sulfurous updater, and we will give it an update method, and it's going to do nothing right off the bat. But the other thing this is going to do is it's going to have an initialize method, and it's going to set the underlying item to equal the item. And like I said, I want this to be regular. And so what I can do now is create a new sulfurous updater and call the update method on it. So we've extracted a method object here. And I screwed it up a bit, but that's a bigger refactoring. That was it was a little bit more changes than I wanted to do, but that's been a pretty common thing. And now that we don't use that, we can remove dead code. And actually, there might even be a way. Okay, so there is no extract method object. There's an extract module. And so that would give us, that's not what we want though. That would give us multiple inheritance. That's not really what we're looking for. So instead, what we want to do is, I just want to run this extract method object refactoring a little bit differently than the first one. It's going to basically look like this, but instead of that, we're going to do this. And instead of this, we're going to say basic updater.new. We're going to pass it the item. We're going to call update on it. And that is a little bit more of a traditional extract method object refactoring, but I should probably look up in the Fowler book exactly what the safe mechanics of that are. We can now take this though and run our inline method, automated refactoring. We're going to do the same thing for this aged brie. I'm just going to keep copying this no-op updater, pushing this in there, doing, oop, JavaScript rubbed off there. We should be at passing tests. All right. let's see. It's the only usage. No, we want to inline it. So there we go. And then the last one is backstage passes. So backstage passes updater. Let's see if I have in my buffer here. Nope, I don't. Oh, so that's, we're all out of time. Just want like a couple more seconds though, because I would like to complete this so that we can see. What this kind of looks like. So we get passing tests because we've extracted that method object. And then if we look, we should have only one usage, and we should be able to inline that method. And we've ended up where our update method now kind of looks, well, it definitely looks much better than it did before. It's also getting to the point where we could, in a fairly straightforward way, add a conjured item. It's not quite there yet. I would like to be able to make a small change to a conditional and just add an object. But that will probably come in my next practice session. It is looking pretty good though. We have a basic item updater, which we probably should have called basic item updater. Let's just do that now. Rename. And we can do, I wonder if there's a shortcut for this, do refactor. So basic item updater. And we can see the logic for all the basic items for age free and for backstage passes. It's not, there seems to be something in the data here where there is, the common thing is that there's a threshold and there's a way that quality changes and a way that sell-in changes. There's actually two thresholds, one for sell-in and one for quality. And that seems to be something in common. And I would have liked the kind of mechanical part of the refactoring to have gotten towards something that had those, what seems essential, which is those thresholds and those deltas. But it's still like a lot better than where we started. And we might be able to get there next time. So thank you for watching if you managed to watch all of this. And I'll see you next practice session.